Hello, everyone. Welcome to our final meeting of the quarter. Today we'll be going over the basics on Python. So we'll start out with what's the purpose of Python, and it's essentially so you can repeat a process once, never have to do it again. Rigging takes a lot of time, and the more time we can spend on polishing and bug testing as opposed to building the rig, the better. Scripting allows for a process to be automated, allowing less room for human error, essentially. So you can make it so if you make a mistake, all you got to do is tweak a few lines instead of troubleshooting to find where that problem exists on multiple rigs. Basic setup. When you're making a Maya script, you need to access the Maya commands because Python scripts don't allow you to do that as opposed to Mel, or maybe some Mel commands and other items. In order to do that, you'll need to import some modules. It's kind of like plugins. For example, you'll import your Maya commands or your Mel commands, and you'll import. So in order to do that, your keywords are import and as. So we'll be typing in import, maya.cmds, as, which will define what our prefix for these commands will be, cmds. So if I were to use the list command, I would type cmds.ls. As opposed to Mel, I would just type ls in that case. Then we delve into the value types. We have integers, floats, booleans, arrays, and strings. Integers are whole numbers with no decimals. So it's like 1, 2, 3, 4, 5. And you can turn a float into an integer by using this command. Int, open parentheses, 5.0, or whatever float you have, close parentheses, and Maya will typically round your number down, as if you divided 5 by 2. If you divide 5 by 2, you will get the result of 2 in Python with integers, as opposed to floats. You'll get 2.5. Float, numbers with decimals, so like 1.9, 3.5, 3.9. You can turn integers into floats by using this command of float parentheses 3 close parentheses. That'll give us the result of 3.0. A boolean, they're a false state, a true or false, or a 0 to 1. 1 being true, 0 being false. Typically, they're found in flags, such as the construction history flag, which you can turn on or off, or with true or false. So if I type cmds.circle, I can type construct ch equals false to turn off my construction history. Next, we're delving a bit into lists, which are with arrays. It's the actual grouping of those data in a list. For example, the list of A is equal to A, B, C, and D of those strings. And you can access these items by typing A, or whatever your list name will be, and then open brackets. Whatever's in these brackets will be what you can use to call up these numbers in a list. Note that Python starts counting from 0 instead of 1. So A is equal to number 0. 3 is equal to D. To keep this automated, however, because you don't know that there will always be 4 items in a list, you can start counting backwards to get the relative but precise actual last item in your list. So in this case, -1 will be equal to D, -2 will be equal to C, -3 is B, and -4 is A. -5 will give you an error, and 4 will give you an error, because no such item exists in the list. Finally, we have our string. They're words, such as hello, and are typically marked with a parentheses with a double or singular apostrophe. Be sure to keep that consistent, however, in your script. They can be used for naming of an item, such as the name flag in your creating of a circle. Next, we have variables. They're similar to algebra. They are an easily accessible alias for data in your script or scene. For example, x is equal to left foot control. They're great for being able to access the data without having to continuously type it out, and also it is a one-stop shop for being able to replace what the destination of certain commands are. So if I wanted to set the adder, if I wanted to make the left foot control go left, right, up, down, activate, create a couple attributes on it, and connect those attributes, I would have to just type in left foot control, but I could just type in X as the destination for all these commands. And if I change this from the foot control to the knee control, all I'd have to do is change the foot to knee in the X item, and then it's updated for all the script, as opposed to having to go through and manually change the foot to a knee. Next, we have lists. They're like variables, but on a larger scale. They can group together multiple items in your script or Maya scene. And you can manually list items together in a script like this. A equals 1, 2, 3, and 4 inside of brackets. You can also list items together with a similar suffix or prefix, using the list command, or the cmds.ls if we're still using the same suffix. In order to do this, you'll need to type out a string, or you can type in another list and have a list reference a list. In this case, I'm using the asterisk to reference everything that has the suffix of control. The asterisk does not take into account anything before it, so all I'm looking for is all these controls. And this script, in theory, lists all controls in your scene in one list. Another example of how to use asterisks is to use them to interconnect a bunch of keywords together in order to find a bunch of controls a bunch of specific controls. So with this control, I will grab every left leg bendy control, no matter of which number they are, because I'm ignoring all numbers or other words in them. All they need to do is have all of these words in them in this similar relative order. They are also useful for appending items to a list as you make them. For example, you can create an empty list like this. A is equal to open bracket, close bracket. This means it's empty. Say you are creating items and want to add those to a list as you are making them. A.append with the open close parentheses is what you'll want to go for. We'll put con in those parentheses, and it will append those controllers to our list as we create those controllers. Next up, we'll want to go over the for loop. It allows you to iterate a series of tasks through a list or amount of objects. For example, for I in A. For and in are keywords here because they define what I and A are. A is what our list is, and A is what our large list of items are. It's all of our controls, for example, or all of our joints. I is the specific number of joint or control that we are going to start by iterating these commands are. So if I type, for example, for I in A, and we go through these list of commands once, we are executing all of these commands on I, the first item in the list. Then I changes to the second item in the list, and then we go through that list of control commands again. You can then expand these into two other functions. Range. It iterates a number of commands multiple times on a list of integers and numbers. For I in the range of 100 or for I in the range of our list. This list would have the number of items in it be converted into integers. So if my list is equal to like 1, 2, 3, 4, 5, it will execute these range of commands 5 times on those items. But when we go to for I in range of 100, and the first go around, I is equal to 0. 1, 2, 3, 4, 5, 6, etc. as we go through it. Length. It discerns the number of items in your list. It also pairs well with range. So for I in the range of the length of our joint list, in our joint list for this example, let's just say it's equal to every joint in our scene. This would iterate through our joints in our scene while also allowing us to call on their names for organization. Say we want to set the adder of a specific control that we create, and it set its translation x to 5. We can therefore type out control, and because we want to reference that specific control, we can open the bracket and type I. So I, that control, is what's getting iterated on. So control 1, control 2, control 3, etc. And we'll go through it, all these commands. Lastly, we have the if statement. It's also described as a condition statement. It is a series of commands that happens when a condition is met. So you have two key parts here typically. You have if and else. If is where you type the condition. Say I want to check to see if there is a joint named left shoulder joint in the scene before building a rig. The Obj Exists command is how we would check to see if something exists in the scene. So I would type if cmds.obj exists, and then I type a string. So this string would be left shoulder joint. And then make sure you put the colon right there, because that's what we should use. Make sure to put a colon at the end of your if statement or at the end of your for loop, just so that you can then I'm figuring out how to word this. So when we set a colon here and we hit tab to start a new line, it will indent it for us. That is how Python that's how Python, and typically you are able to read scripts easier, so that we can know which commands have a for loop on them and when we exit a for loop or an if statement. Because indentation is very important for this. If statement. So yeah, so now that I have this typed out, if this is true, if this command executes and finds a left shoulder joint, then I can do whatever I want with it, and everything below it will happen to it. Like I can build a rig for the shoulder or whatever. Else is what happens if this is untrue. If the condition isn't met, let's say I want the script to skip this section if there is no shoulder, because if there's no shoulder, I don't want to do anything anyways. So I would just type else and then hit my return key and type in pass. Pass is a command that just skips past it. So no rig will be built if this condition is true. With that said, I was thinking of maybe running through a quick demonstration on like how to use a fair amount of these commands, just through like a basic FK rigger, essentially, just to kind of go through that really quick. And then and I was thinking we could have like an open discussion on like if everybody has any like general tips and tricks on like using Python, so that we can get like the most out of this meeting. Are you guys cool with that?
Sounds good.
Dope. Let's see, gonna share my screen really quick. Okay, you can see my 2019.
Yeah.
Okay, dope. Just gonna. Okay. So, oh, my mouse is connected. There we go. So for this, I'm just gonna slap a couple joints around because we're just gonna be building an FK chain. But after that, I'm going to pull up this and go and find the script editor really quick. There we go. Where is it?
So make the text bigger because it's a bit fuzzy.
Okay. Yeah, I'll just do that, and then there we go. And I'm just going to delete this. So we have this joint chain, and so first of all, we need to do the first part of one of the slides we mentioned. We need to import a bunch of modules so we can actually use some of the Maya commands for this script. So for that, we're going to type the command import maya.cmbs. So that'll just reference the Maya commands module. And then we'll type as, so that we can declare a prefix for those commands to be able to use them and know where we're referencing this. As, and for this, you can type MC, or I just type CMDS because that's just what I've gotten used to doing. And often you'll find yourself maybe using mel commands. So I just type import maya.mel as mel. So in this case, we're going to get I'm just going to, let's see here. Yeah, we'll just leave these unnamed for now. But for the case of variables, let's just say x is my variable that I'm going to name it, and it will be equal to joint1. So if I cmds.select x, and I'll just clear my selection really quick, it'll select joint1 because it's referencing the string, and it will select that string. We don't want to create a bunch of variables for we don't want to create a bunch of single variables for this. We want to probably create a list. So we could type cell is equal to and just start typing out a bunch of strings, but that's also that's also very tedious. So what we can also do is type cmds for my command .ls, and I will just select the ls or the command, select whatever glows blue essentially, double click it to select it, and then right click and hold. There, you'll find like a little box here full of items you can look for, and I usually go to the second one, which is quick help. So you can find a bunch of flags that you can use with this command. And for the ls command, if I scroll down, we'll find the selection flag, or SL. And for that, I'll type SL is equal to true, because selection is a Boolean. It can be either off or on. So it will essentially, I can select all these joints really quick and go to print cell to show me what's in the list of cell. And it'll show me all of the joints that are in here right now. Afterwards, we've now got a list of items, and now we want to execute a bunch of commands on them or build a rig for them, just to keep things a bit simple. So for that, we need a for loop. We're going to type for I in cell. And after we do that, we can now that I put the colon in there, you'll kind of see what what I'm referring to about indentation. Before I do that, okay. So if you see this command bar right here, this command option right here, you can scroll down to where, if you open that up, you'll have new tab, rename tab, select tab, delete tab, but then you'll have a bunch of items with checkboxes in there. What you want to do is click on the checkbox for use tabs for indent, because the way that you space things out and the way you like tab things in can definitely affect your script. Because if I did this and hit the tab key, that is registered as one key right now, instead of if I hit space 4 times, and that is essentially the same space as a tab key. However, Python registers that as 3 separate keystrokes, and it will get very confused if you mix up multiple spaces instead of in tabs. So if I had like tab space 4 and mix those two together, I would probably get something about unexpected indent, and my command would just never run. So definitely just make sure you're setting yourself up for no real confusion by going to command, use tabs for indent, because that will just probably save you a lot of time and headache. But now that we've got our for statement set up and we hit the return key, you'll see that when we hit the return key, we're instantly 1 tab indented inward. So we can declare that we're under this, it's kind of like a hierarchy. We're basically parenting these commands to this for statement to kind of keep it simple. So firstly, what I want to do is create a controller. So we're going to type con as our variable for this for these controllers, and make con equal to cmds.circle. And if just to illustrate that, if I click on the circle button, you can see that in the mel bar, or in the script editor's history, it'll type things in the mel format. So you can see that the command is circle, and these are just a bunch of values that we can access if we wanted to. But for the case of this, all we really need to access is the name, which is right here, a name, which is equal to a string. If I extend it out, you should be able to see the data types in some areas. So name, which is a string, and instruction history, which if you look at here, it's on or off. So we know that that's a Boolean. To keep things a bit simpler and more like automated, the name will be equal to not a string that we type out manually, because we're going to be creating a bunch of controls. Instead, we're going to reference I, because that's the current object we're iterating on. So we'll make that equal to I plus a suffix that we want at the end, because there is no suffix. However, let's say that I went in and named these like joint1 underscore joint. What you could do instead is I.replace, and then you'll find like the suffix of joint here, comma, and then replace it with a suffix that you want, so control, and then close parentheses, and then close it again so that you can close this little like area of flags. But since we don't have any suffixes, we're going to just type I plus underscore control. And then we're going to hit comma and go ch equal to false. So there's no construction history on these controls. Next, we're going to want a control group to hold these dirty values that we're about to give to it so that we can actually use these controllers. So we're going to make a new variable, call it group, or grp, equal to cmbs dot, and if I go to the create menu, and I can create like an empty group. That's not right. So if I hit Control G, it'll type do group, but actually what we want is to just type cmbs.group. Let's see. So we'll want 3 flags in this statement here. We're going to want the name string, the empty, and the world, because we want the group to be empty. We want it to be parented to the world at the origin so that we don't have to worry about anything there, and then we want to name it, of course. So the name string, to keep it fast, will be equal to I plus underscore control group. Empty and world are both booleans. They can be set to off or on. So em is equal to true and world is equal to true. Afterwards, we're going to want to parent our controller. So cmbs.parent our controller to our group, and that's all we really need to do. So yeah, after we do that, we're going to want to, if I run this script really quick and I just run this right now, you'll see that we have a bunch of control groups. They're all in the middle of nowhere in the scene, and they don't do anything. They're just kind of sitting there. So next we need to place them. We're going to essentially create a new line, and just to keep this a bit easier so we don't have to create a variable for it or delete it later on, we can actually do this really quick to create a parent constraint and place it, because we're going to be using a parent constraint to place our controls. I'm going to type cmbs.delete. So whatever's in this bracket will be deleted, but if we run a command first, that command will run, and then we'll delete that command, or whatever item is created from that command. So we're going to type cmbs dot. So if I, just for reference, if I click here, click on the joint, and I go to rigging parent constraint, which is right here, you'll see that parent constraint is the command that comes up. So if I go to cmbs dot parent constraint and open parentheses, close it, and then close it again for the delete, what we're going to reference first is our joint, or our parent, that it will be controlling whatever we want it to. And in this case, a parent constraint with maintain offset will snap it to wherever our joint is. So we want our control group to go to our joint. So for that, to declare that, we'll want to type I to reference the joint that we're currently iterating on, and then we'll want to put our group in there so that we can have the group be the parent, be the child in this case. Oh, it's like I lost it really quick. I'm just gonna. I accidentally right-clicked when I shouldn't have. There we go. Oh, I actually just deleted the script. Never mind. Delete that. So if I double-click here, go to the quick help of it, you can see that we also have a maintain offset and a name string. Maintain offset is by default set to off, if I recall correctly. But you can also just declare MO is equal to 0 so that it's off. And if we run that really quick, you'll see that all of our controls are placed. But we don't even really need this. So if I just delete the maintain offset, leave it with I, comma group, all the controls are now placed in there. However, the problem we have here is that that they're also deleted. Also, these controls can't really do anything. They just don't control any of the joints at all. So to fix that, what we'll need is the cmbs.parent constraint again to have our con control I. And maintain offset is equal to 1 just to be safe, because you could just run into issues. I also just like to keep maintain offset on anyways. So select all these joints. And if I zoom in on these joints, you can see that I am essentially controlling them. Here's the problem. We currently still have to parent all of these controls together. Which is always when we're already automating all this much, you'll definitely feel a bit lazy about wanting to do that. I'm just going to zoom out really quick. So, okay, you can still see the script editor just fine, Rob, right?
Yeah.
Okay. So this is kind of where the if statement comes in when we want to parent these joints to their parent in a way. We're going to go to the top here and start and make a new variable, and we'll call this the parent joint. What we're about to do is going to reference the current joint that we're iterating on. So if we're going through it one time, it'll be joint one. Let's just use joint one as an example. So we're going through joint one and we're creating its controls. We're also going to reference if it has a parent or not. And if it has a parent, we'll parent the control group to that parent in a way. But when we get to like joint two, its parent will be joint one. So we'll parent the control for joint two, and we'll parent it to joint one's control. So in order to do that, we'll need to set this up really quick. We're going to type parent joint equals cmds dot list relatives. List relatives allows us to essentially query or edit the or find the parents or descendants of our of whatever item we have listed under it. So it'll be an open close bracket and the parentheses. And first we're going to type I so that we can declare that we're referencing the current object being iterated on in this for loop. And then, as you see here, we have parent, which is a Boolean, and we're going to reference to see if it has a parent or not. So we'll type P equals true or 1. After we do that, we can move down here after we create our control and parent constraint everything together and such, and we'll go down a few steps just so this is just how I typically keep things a little organized. And we're going to type if pair joint. So if pair joint, and if it has a parent and that's equal to true, or just if pair joint, we'll hit the enter to go down. We're going to have these commands run it to allow it to be parented to its parent in a way. So firstly, we'll need to take the pair joint and define what its control counterpart is. So we're just going to create a new variable, call it pair con. And now we're going to define what paracon is typically going to be equal to. Paracon will be equal to pair joint, and this is going back to how we reference items in a list. We don't want to, this is technically going to be considered a list of items because it is now referencing the parents and stuff. So we need to reference a specific item in this list. And we need to open bracket, type 0, so that we're referencing the first item in this list, which will be whatever I is equal to. After we do that, depending on if you have a suffix or not, we will declare what the new suffix is. So the suffix, the way we've been naming things hasn't been by replacing a suffix. It's just been adding a suffix to these things. So we'll type pair joint 0 plus our control suffix. And if we did have like a dot joint underscore JNT suffix, we just type replace underscore JNT with control. So now we got that pair joint. If we are creating joint 2's control, it will reference pair joint 0. It'll reference its parent, which will be joint 1. And in this case, its control is just named joint 1 control. Lastly, we're going to just parent it. So we'll type cmds.parent, the current group that we're creating. So if we were still in the joint 2, it'll parent its control group to the paircon. And if I select all these joints, we see that we now have one hierarchy created. We can go right here and just grab our controls and move them around and just do kind of whatever. In regards to, just really a quick mention, in regards to figuring out the specific commands in Python, typically I find myself either just doing something in Maya. So in the case of joint, creating a joint, you can see that the command is just joint, or or like when I create a locator, it's just called space locator. Or if I don't know what I'm really doing, I just look it up on Google. Like I just look up Maya Python how to do this essentially, and that'll typically do it for me. And you'll eventually find a bunch of commands that you're just used to using, and you'll just use those over and over again. But with that said, does anybody have any questions over the demo that I just did? If not, we can totally just move into the general open discussion on like general tips and tricks from James, Mason, Kenny, or anybody else who's really experienced in Python here, just so we can all kind of spread the wealth on that.
I do have a question. This is my first time joining one of your meetings, so hi.
Hello.
Are we? Is there access to the PowerPoint?
Yes, I can absolutely share this PowerPoint afterwards. After the meeting.
Mhm.
Yeah, I just need to go back and like fully record the rest of the PowerPoint because I realized that I wasn't recording like a dumbass. Yeah.
Okay.
So
All right,
yeah.
cool.
So are there any other questions about the demo?
Did you record that demo?
I did record the demo. I'm double checking.
Okay.
Yep, still recording. All right. Yeah, so I recorded that demo. I can put it up after, hopefully tomorrow. But yeah. So yeah, Kenny, James, Mason, anybody who's like really good with Python, do you guys have any like general idea, tips and tricks that you can give to anybody, if you could?
It's scary at first. It's always scary at first. I mean, if you want to do rigging, like, if you think you can get away with not using math, too bad, so sad. You chose this path, so you're gonna have to accept it for what it is.
True.
Pardon.
I had quaternion rotations kicking my ass last night.
Was it the scaling? Was it the scaling shit?
I was trying to do like a new matrix-based twist extractor,
Okay.
and yeah, I finally got there. But yeah, like you said, math is inevitable.
Yeah.
But yeah, also about Python, automation is key. If you find yourself typing something over and over again, you're gonna want to turn it into like a definition or a method or function, whatever you want to call it. We didn't go over those today, but you could find like about how to do that on sites like Stack Overflow. Stack Overflow is definitely like a lifesaver for me. I go there a lot just to find out about basic Python stuff. But yeah, just modularize anything that you're gonna do repeatedly. So for like that control script, oh wait, what am I talking? That was that a single function or just a series of commands that you did?
It was.
That wasn't a function. That was just commands.
Yeah, it was all just commands. Okay. The only anything I really
Okay.
imported was just Maya commands. That's really all I really needed from these.
Okay. Yeah. So like turning snippets like that into like a single function where you can like put in like the list of joints that you want as like a parameter. So feed it that, and then it'll know what to do with that automatically with just having everything that you typed in place.
Yeah. I think maybe this is just me, but I also prefer regular coding classes to like ones that are specifically for Maya.
Just so you kind of understand the fundamentals.
Fundamentals better. Yeah, because if you like lack fundamentals or didn't do any coding like in your high school or whatever, like you're gonna eat shit like in like the most like blunt term possible, because it's gonna really bite you. So yeah, just preference. You don't want to. I mean, you should jump into it like as soon as you can if you're a rigger. Especially with like doing FKs and like what Brandon just did. Like, you know, if you could just automate that, like, you know, you don't have to worry about anything. Like, and then eventually you do arms, and then you do legs, and then you do auto riggers. Because in the industry, they only use tools. They don't do this weird like arcane dinosaur shit that we're taught in these classes and stuff. Like they're just using tools that are already built. You're just focusing on skinning.
I can like totally vouch for what James is saying. I learned Python through Maya. And so this year I had to do like different Python stuff. It was with like Shotgun and the Shotgun API. And I was like,
God.
okay, I can do that. And I started doing it and I was like, what the fuck? It was super confusing. And essentially what I've learned is that like the Maya API is incredibly horribly written. It's like really in the way that most of it's set up. So like most other APIs are much better and easier to work with than the Maya one.
So for learning the fundamentals, oops, sorry, go ahead, Ken.
Oh yeah, like going off of what Mason just said. I don't know if I actually can say I really know Python, you know, because I mean I just got into it through Maya, so I can make shit happen in Maya with Python, but like outside of that, I really don't know, guys. I don't know.
I mean, I kind of agree with Kenny, but what were you gonna say, Trent?
I was just gonna ask if I've like tried learning Python on and off like throughout the years, but never really like frankly stuck to it at all. Like past like the general like hello world command that you learn in like the first lessons and stuff like that. But what would you guys like if you guys have found like learned like Python stuff outside of Maya, like what resources have you guys been using to learn that? I know, James, you were looking at Code Academy for a while, but
Code Academy is pretty good.
Okay.
They give you an intake. I mean, they give you just detailed stuff. Like, I'm not quite sure what Maya uses, what version of Python Maya uses. Is it 3?
No, it's like
2.
It's version
like 2,
which sucks.
Yeah, it's garbage, right? Okay. Yeah. So like Code Academy, like they have I'm not sure if they have 2, but they definitely have 3. But the fundamentals of 3 are the same as 2. There's just certain things that 3 is updated. But I recommend Code Academy because like they just kind of baby you through it, which is like great. Because like if you're not someone that clicks with math very easily or hasn't been coding like at all, like you know, like it's good to just take baby steps. Like I don't see the only problem is that you kind of have to like discipline yourself to like, you know, go back on the website and like constantly do it at least every week.
Right.
Like, but also like there's gonna be things in Maya that don't apply to regular coding because Maya is so shit. Like Mason was saying, like because it's severely like it is outdated arcane. Like that's why everyone makes like thousands and thousands of plugins because it's so freaking broken.
I will say that I am a big fan of PyMel though. Even though it's like a little bit slower than like
It's
Maya
heavier,
commands. I really like PyMel because it makes a lot more sense. It's a lot more easy to understand like as you're writing it, I guess.
Right.
PyMel came in was like really big handy for me for like this naming thing that I was trying to figure out. Because everything in Maya, it's like you don't get access to the actual like objects because everything is referenced through strings. But PyMel, you can access the actual node and get like the node name, and so that was like really great. But Yeah, it was the speed issue because like every time you refresh your revert your module state and with the charcoal editor, it has to load up PyML again. And for me personally, my workflow, I was like always re reiterating every time I'd like make a change and like I'd revert and load up the script and run it, and then it's just that 5 to 7 second wait as it loads up. It wasn't quite practical for that, but otherwise, I mean, I think it has huge advantages, like Mason said.
Actually, I had a question for Kenny and Mason. You guys use charcoal. How much is it, and is it worth? Like, is it what are the huge advantages it has over just the regular script editor?
Do you want to take this, Mason?
Yeah, I think it's like, let me check. It's a little bit pricey.
I think it
But
was like $60-ish. If I remember
yeah, it's
correctly.
let me check it out real quick. On software. Okay. It's $80 now, but I would say that it's incredibly useful because it has like autocomplete. It's made for scripting in Maya. So there's a lot of things that it simplifies and makes exponentially easier. It also lets you work in like projects like you would with another like application too. So it's very, very easy. The other thing that I use for like bigger projects is Pycharm. And you can set it up so that it runs when you like run scripts in Pycharm, it connects to Maya and like runs through Maya. And I like that because it checks all of your syntax for like anything in Python, which is really convenient. So it keeps it like to follow the like Python formatting standards that you're supposed to do. And if you like write something that's convoluted, it'll be like, oh, do you want to reword it to mean this? So I like Pycharm a lot too, but I would definitely look into Charcoal Editor if you script more than like once a day, then I would get Charcoal Editor because it'll make your life so much easier. I honestly can't even express like why it's easier. It's just better.
It's just, yeah, you try it out and you'll see. Well, I mean, you'd have to buy it before you try it, but it definitely made, like, I can't imagine like doing what I've been doing this for my thesis project with the basic Maya script editor. It's just, yeah, keeping track of all these different script files and then just, yeah, having the autocomplete. It's a huge efficiency booster.
Right.